Alrighty folks, welcome to another exciting installment in our quest to develop a controller for the ZF5HP24 automatic gearbox. This is the first run that we're doing with control systems hooked up. You may recall from the last video that we had the box spinning with no electrical connections to it. It defaults to operating in fail-safe mode, which lets park, reverse, neutral and drive operate in fourth gear only. So what we have is my Arduino based controller hooked up. We have connected to the valve block and to the range switch. Got some software in here, and I'm pleased to report that we seem to be getting a bit of success. I'm having to work out some of the valves by trial and error, because some of the data that I have on it is quite sketchy. I think it's more designed for service than for writing an Arduino program, but it's given me enough of a guideline that I can actually work out what valves to operate and when. So what I'm going to do, well, what we have at the minute is we have this multimeter is driving me crazy. Sorry about that. Okay, what we have at the minute is a program in here that responds to the range switch from the shifter. So at the minute we can go PRND. What happens when we go into D at the minute is that we just select first gear and stay there. I have also messed about with some of the program here that lets me go to second gear and third gear. Obviously the next phase in this operation will be to write the software such that we have some kind of external control here that will let me shift the gears on the fly. But just for the minute, just to get a feel of things and to test the validity of the control system, we're running it just in first gear in drive. So I'm going to start up and we will run through what's actually happening, and then I'll do some more close-ups on this and run through some of the software. And I'm also going to set up a section on the evbmw.com website that I'll dedicate to this project, and I'll upload the software to that. And if anybody wants to obviously get involved with it, all of this software, hardware will be all freely available to anybody that would care to duplicate what I'm doing here, though. Can't see why anybody would be that mental, but I suppose it takes all kinds. So yeah, that's my way of saying if anyone wants to help me, then please do so. Okay, so as before, we have our 24 volt supply to the motor. What I'm probably going to do with this as well, I've secured some AGM batteries which I'm going to set up underneath the bench here, and we will rig those up to a controller. I have the original air-cooled controller from the 3 series that should work great for that. Because part of this as well is to look at the whole idling the motor. That end of things we need to have a look at. As some of you will be familiar from my past videos, most of my controllers are based upon the open revolt control board which I've modified for various purposes. And the feature that that particular controller doesn't have at the minute is the ability to idle a motor. So we need to have a look at that functionality to add on to the controller as well. So there's quite a bit to do here. That being said, we're quite fortunate with this gearbox, as far as there's actually 3 speed sensors in this. And what I've done at the minute, I don't have code or hardware in the controller to read the speed sensors. Because what we're going to be doing for the speed sensors is they're Hall effect reluctor ring type sensors. So I am going to be use an LM2907 frequency to voltage converter chip that will take the variable frequency from the turbine speed and output shaft speed sensors and feed that into the analog ports on the Arduino. And we can then determine shift points, hopefully, from that, because we can determine vehicle speed and determine turbine speed. So that's probably enough of me yapping, so let's crank this thing up. So right now we're in neutral, and I'm just going to start up the motor, and we'll run through, we'll run her into drive, and we'll be able to look at the speed sensors on the oscilloscope. We have turbine speed on channel 2, which is on the bottom, and we have output shaft speed. This is some kind of a screensaver thing on it, which is really annoying me as well. And we have, I've just forgotten what I was saying. Okay, right. On the oscilloscope here, on the bottom, on channel 2, we have turbine speed, and on the top, channel 1, we have output shaft speed. So let's crank her up. Where's my contactor, spanner contactor? Right, heads out. Okay. So what we got right now is we have neutral. And now that the gearbox is under control, we will observe that the output flange is not actually spinning in neutral anymore, and I can actually grab it and rock it back and forth quite freely. So that's good. We have turbine speed, obviously, because the turbine is spinning. And we have no output shaft speed because that is stopped. So what we're going to do now is we're going to pop into drive, and the controller will detect that we've gone into drive and will engage the valves to give us first gear, hopefully. Don't be surprised if it actually doesn't. So here goes nothing. Drive. So what you'll have heard there, is you will have heard the motor load up, because part of the program is that we bring up the line pressure. So right now the output shaft is spinning slowly, as we'd expect from first gear, and we have now we have a detectable waveform from the output shaft speed sensor. So I'll grab the camera, we'll do a little bit of a look at that in more detail. So, on our oscilloscope, as I stated, on the top we have the output shaft speed, which being in first gear is quite slow, as we can see there, turning over nicely. And on the bottom we have the turbine being the part of the torque converter that spins with the gearbox, doing its thing there. So our controller right now is running some very basic software. I don't know if you'll be able to see the screen here, whether it's going to just grey out on me, or it doesn't seem to want to work for some reason. Stupid. 20x4 LCD, which is not at all visible. And we have some electronics in here which I'll run through in a minute, and our oscilloscope probes are hooked up to the speed sensors. And those have some 0.1 microfarad capacitors in there just across the speed sensors, just to take out high frequency noise. So right now we're running in first gear. So we can see here, nice slow speed. Now what I'm going to do now is I'm going to set this up a little bit here. Everything's done on the fly here. There's no prior preparation because that would prevent pretty poor performance. So I'm going to just let the camera see the oscilloscope. And what I'm going to do is I'm going to turn off the power supply to the solenoid valves. And the gearbox will revert back into emergency mode and we'll see what happens. Here we go. So, gearbox is now back in emergency mode. As we can see, the output shaft speed now closely matches the turbine speed, because we're now running in fourth gear at maximum line pressure. So I just take the camera up there, see our flange is spinning away at nice high RPMs. So if I now re-establish the power to the solenoids, that we go back into first gear and our output shaft slows down. So if I now pop us back into neutral on the shifter, you can see the turbine speeds up slightly and the motor is not under any kind of speed control, it's just running on 24 volts DC at the minute. Our turbine speed increases and our output shaft speed decreases, or stops I should say. Now if we go into reverse, I'm not sure if it's 100% happy. Actually, now that I think of it, I think I know why reverse might be that happy. Now what I'm going to do is I'm going to see here for a second. I haven't a clue what I'm going to do here, so let me just set the camera up there so that it's on the adapter plate without tipping over, hopefully. So what I'm going to do is I'm going to change a part of my software here just on the fly. So let's have a look at what we're doing here. I hope to God you can see this. Oh, okay, that's a bit better. Okay, so this is our subroutine that's handling drive at the minute. Now the software is very messy, so you're going to have to forgive me for that. I have to clean it up and sort out the comments and that. But reverse was giving me some high currents and that. Now my line pressure I had set to 50%, but maybe we don't quite need 50% line pressure when we're in reverse. So let's reduce that a little bit. And what we're going to do now is I kind of have a little bit of fun with this. I'm going to upload the software to the Arduino, and obviously when I do that the Arduino is going to reset, and when it does the gearbox will kind of jump back into emergency mode when the valves lose drive. So then it'll jump back in when the Arduino resets and goes back to neutral. So let's have a little bit of fun, and we are compiling sketch. There we go, valves have dropped out. And we're back. So, there we go, fun games. Now, let's see what happens when I drop into neutral, or into reverse. Right now, in neutral, with my oil starting to warm up, I I do have the oil temperature sensor wired into an analog input, and I have some data points on that particular sensor, so I just need to write a little bit of code to calibrate the sensor. It's just giving me a raw value at the minute on the LCD. So right now I'm at 50 amps at 24 volts in neutral. So let's pop her into reverse. So right now we're in reverse. And yeah, it's a little bit better actually. My line pressure, reducing my line pressure there in reverse kind of helped me a little bit. I think my EDS2 and EDS5 valves may need to be played with in reverse as well, because I actually found that to be the case for first gear. So there we go. As we can see on the oscilloscope here now, we've got low speed on the output shaft and still reasonably high turbine speed. So back to neutral. And as the fluid heats up, I've noticed that it's becoming a lot easier for the motor to turn the torque converter. And also for any of the kind of noises are going out of the gearbox as the fluid heats up, so it's quite good. Right, so let's do one more run into drive in first. So should be able to see now. I'm drawing about 56 amps. I have a 12 volt power supply here that's supplying power to the controller. It's at 12.5 volts and just under 700 milliamps at the minute. My spanner contactor provides an emergency disconnect in the event that something goes horrifically wrong. I can just slap the cable straight off that claw on the spanner. My high quality car batteries and power supply to try to keep them juiced up. So there we go, that's first gear. So what I'm going to do is I will shut down and we'll walk through some of what the Arduino is doing and some of the parts that I actually have in there. So stay with us. Okay, so inside our controller we have a few fairly simple building blocks. We see here on the top is a component that I've spoken about before. This is this LED driver shield that I purchased for the Arduino, and I believe it's intended to be used for running high power LED strips and stuff like that. But what it has quite usefully are a number of high current MOSFETs on there, and all the kind of connector block and capacitors and resistors and gate drive bits all set up here. So that guy just plugs straight onto the Arduino and gives me the ability to basically have, I think it's 6 PWM channels which are on here, and 4 just digital channels, and I think get about a couple of amps each, which is absolutely perfect for driving the valves in the gearbox. Also, you might notice these little guys here, these kind of transistory things. They're actually diodes that I had to solder onto the back of that card, because we are controlling solenoid valves, which are inductive, and they would create spikes without a freewheeling diode to take that out. Now underneath the LED driver we've just got a windshield kit from Adafruit, and I've just got a few components on there just for the temperature sensor, because it's an NTC sensor, so I just need a resistor and a capacitor just to connect that up to an analog input. and as you can see, hopefully down here then it gives us screw terminals with which to connect some of our signals and power both to and from the Arduino. Now over here in this corner, this little silver block, this is a 12 volts to 5 volts at 4 amps DC to DC converter, because from what I can determine, the valves in the 5HP24 operate from 5 volts DC. So that's giving me a nice high current 5 volt feed to my FET card, and then the FET card is obviously fed from the Arduino PWM channels and digital I/O channels, and that allows me to control the pressure regulating valves on this part here, which is the PWM side, and on this part here, which is just the on-off digital side. Now on the front we have my 4x20 LCD, which I'll try and just get you a view of there now. It's not great, but some kind of a contrast issue going on here. It's not a great screen. Now don't mind the oil temperature, it's not 320 degrees centigrade. That's just a raw value from the A to D channel that I'm recording the temperature sensor on. I just have to write a bit of software to calibrate that to an actual centigrade temperature measurement. So I did find a German document about the 5HP24 that has, I think, 4 or 5 data points from the temperature sensor, so I should be able to make a pretty little simple subroutine just to translate that into a normal temperature measurement. So that is about where we're at on the whole situation as of now. Not much else to report today, other than the fact that we are at this point able to shift the box and control the various valves. So it's now down to really developing the code to run it. So that's, you know, arguably the easy part. We've got most of the hardware nailed down. So we'll see where it's going to bring us. Okay, I just thought that we would do just one more run. It's maybe a bit of a better angle than me doing my Blair Witch scenario on it. So again, we're in neutral here, so I'm going to crank up and I'll just run through some of the gears and just show what happens when we don't have control on the gearbox. So what I'm going to do first of all is I'm going to turn off the power just to the solenoids. So you can actually hear them click off inside the valve block. And we're going to start up in neutral. Now we're drawing about 52 amps. We're in neutral. As we can see, we have output shaft speed, which we shouldn't really have in neutral, but we do when the gearbox is in emergency mode. So I'm going to throw the switch, I'm going to bring on the valves and see what happens. So we've dropped in current, and obviously we have stopped spinning the output flange now in neutral. And we're going to go into drive, which will be its first gear. So we're in drive and we're in first gear. As I'm hoping we're able to see there now, we have low speed on the output shaft, both on the oscilloscope and visually. If we were to switch off the valves in this mode, the gearbox will go back into emergency. And we'll hear it rather abruptly shifts into fourth gear. As we can see again by the output shaft spinning visibly faster, and on our oscilloscope we have a much higher frequency from the output shaft speed sensor. So let's bring our valve power back on, and our clutches change inside the gearbox, and we drop back to first gear. So reverse, I haven't done this in because I'm not sure what that's going to do. So let's go to neutral and reverse. Right, the box is starting to warm up, as can be seen from my analog reading on the temp sensor and from the casing. So right now we're in control mode, so let's get rid of the valve power. Oh, big increase in current as the line pressure goes high. Let's bring our valve power back on. Actually hear there the very prominent sound of a valve blowing off, which I imagine is the fact that we're controlling the line pressure and reducing the load on the pump. So if we go back to neutral, and finally we'll pop back into drive one last time. Starts closing itself off once again. So there we have it, folks. We've got some working software right now, at least giving us individual gears in drive. So the next thing I have to do is to get my code a bit more useful, in that I'll be able to upshift from first to fifth and engage and disengage torque converter clutch. That'll be the next stage in the operation. So stay with us. We'll have more exciting updates very soon.